The gas shred node is designed to break apart the velocities in your simulation. So let's say gas shred and plug that into the middle input. That's going to be our velocity update. Let's also visualize the shredding and see what the default things do. I can already tell you ahead of time that it's going to not look like anything. So yeah, we have this really sporadic behavior going on, and you'll oftentimes run into this sort of look whenever this shred is turned up too high. So for the scale, let's go maybe 0.05 and see if our flames look somewhat normal again. Okay, so at 0.05, we're still not normal yet. Let's try 0.01, see what that does. Okay, so it's still not looking the way it should, but at least we have something going on, which is fine for right now. Okay, so I mentioned that it's breaking apart velocity, but how is it actually doing that? Well, it does two things. Let me draw this out. It's very easy to see this. If we draw it out, it's going to either stretch the velocity, so that means go like this, or it's going to squash it, which means go outwards in all directions, trying to squash it like that. So depending on what your temperature value is, there's a threshold for your temperature. So we have this temperature threshold, that's the second parameter. If let's say that is, well, let's just go with 0.75, right? And let's say that the temperature right here is 0.75. What this is saying is that if the temperature is 0.75 or greater, so that means if it's 0.75 or anything here that's hotter in the flames, then we're going to go with this squash effect. And I should also clarify, the squash is not going up in the Y direction. It's just going in all directions except for Y. But if the value is lower than 0.75, then it's going to stretch in the Y direction. It's going to fling it upwards, and that's what's going to cause this lick of fire to happen. It's kind of like this whole squash is trying to take our flames and do this kind of thing with it. And then once it reaches the top, it's going to try to stretch it and give these like little flecks, kind of like that just sort of get pinched off at the top. And that's what's going to kind of create that whole shred look. So that's basically what's happening. Now here's how I would recommend adjusting these shred settings for most situations. Start by turning on this modified temperature through shredding. That's going to modify our temperature field and not just our velocity with this squash and stretch thing, okay? So check that on because it's going to influence behavior. It's going to make it look more interesting too, as we'll see. And the next thing to do is to bypass this gas shred node so that we see the original simulation. And we want to be on the lookout for temperature values that are right in the middle of where we want these flames to flick up. So if we turn on the temperature field, let's go forward quite a few frames, maybe up to about 90, and figure out where we want this to switch over to stretching so that it can throw these licks of fire upwards. So here we are. Keep an eye out on this section right there. That's where I want these, well, let's actually go a little bit higher than that. I want things to start flicking up right about there. So keep your eye on this band, and let's see what value is about right there. Go to the smoke object, under the temperature tab. We're going to middle mouse and drag this until we start seeing the red go away. So right about there. That's 1.8, okay? Now go a little bit further than that. So we want to start flicking this a little bit before then. So that's going to be about, well, 3 or so. It's about a value of 3 or maybe even 2.5. That's when I want this to switch over to pulling this in the Y direction. So let's try 2.5. Say 2.5, like that. And now we get this sort of results. So in general, I like it. I think it's really cool. What I'd like to do now, though, is just bring up this squash. And instead of bringing up the squash here, there's a much better way to do this. Think of this squash and stretch more as a normalized ratio. What that means in English is that don't go past 1, and think of this as like a portion of one another. So right now we're at 0.5. That means we basically have half of the amount of stretch than we do of squash. So let's bring the stretch down to 0.25 and then bring the scale up. That's a much better way of controlling how this shred works, because if you bring the squash up and the stretch past 1 and you have crazy values over here, it's going to be really difficult to control this scale versus the squash scale versus the stretch scale. It kind of, again, gets hard to manage. So let's try that, 0.25 and 1, and see what that does. Okay, and now we have this kind of behavior. So once you have a general ratio of squash and stretch figured out, and you have the effect going just a little bit too intensely, then turn down this clip gradient, and that's going to nicely chill back the effect, or just turn down the whole effect in a way that is better than just doing the scale. So you get this situated first, get all of these the way you like it, just go a little bit past what you need, and then bring down this clip gradient to really get it in a nice spot. I decided to go with a clip gradient of 4, and I actually turned that stretch back down to 0.25. So I think at these settings, I like how it looks, but play around with this yourself and see what general areas or what general looks you like to see. But the cool thing is that now our flames just have a little bit more of an interesting character to them because we've altered the velocity in this sort of way. And that is the main workflow that I'd recommend going through with shredding. The most important thing that you need to get right is this temperature threshold, this scale, and then also using this clip gradient to just sort of dial it in once you've got it in a decent spot. Let's also go to our volume source and bring in the amount of fuel to maybe about 175 or so. We did lose a little bit of intensity through the velocity changes that we've made, and I just want to make this fire a little bit more intense. So we'll turn that up. Let's see what that does. And there we go. Now we have this. A lot of that shred effect is also going to get better as we turn up the divs. So I think that we're looking pretty good. I now want to talk to you guys about how to cache this out, or I guess different thoughts on that. When we go to do the final resolution, which might as well get it set up right now, I'm going to go for probably about 500 in this uniform divisions. When you do that, also be sure to go over here and turn off Use OpenCL because it's probably going to cap out your graphics card. And also be careful because on this gas shred, the Use OpenCL is checked on by default. You don't want that crashing in the middle of your sim overnight. So just uncheck that to be safe. And now that we have that, let's go over here to our Pyro imports, which is right here. If we middle mouse, we have density, velocity, temperature, heat, and fuel. We want to keep this velocity in calculating motion blur. So let's keep all that. We need our smoke, we need heat, and we also need temperature. The only thing that we can probably get rid of here is fuel. So delete, and we're going to say delete fuel. Let's also middle mouse. You'll notice that we have standard Houdini volumes here, and we can actually reduce the footprint, that is how much memory this is taking, how big the file is, by a decent amount by converting to VDBs. So VDB converts, or convert VDB, right there. Go VDB. And yeah, now we're down to about 29 megabytes versus 31. So it's not really huge. But in this case, I think it's nice. Let's also get rid of some of these detail attributes that we don't need. So let's say clean. and say remove all attributes except for name. The name here is actually what specifies the volume. There's our volumes, and that'll work out just fine. Let's go back to our DOP network right here and change our substeps to 2. I at least like having one substep to this. Normally, when it comes to pyro and explosions, like we'll see in Pyro 3, I have a different method for doing this, but in this situation, I think 2 substeps will be just fine. Also, be sure that you have enough disk space at hand. 500 is a fair bit of resolution, and so you don't want to be running out of disk space on your computer. Let's also double check the bounds while we're here. So as we do that, let's turn this down to like 2 or something. And just be sure that we have enough room going on. I'm going to bring this up just a little bit. So we'll go up like that. And now we can turn this back up to about 500. Let's also take our gas resize fluid dynamic and add a little bit of padding in the Y direction. I always go a little bit in the Y, a little bit more overall, so 0.08 for that. And let's also add maybe 3 delay frames so that we're just playing it safe and that it's not going to really cut this off. If we had a more violent explosion, I'd want to test this a bit more, but I think that what we have here will be just fine. Okay, so whenever you're ready, cache that out. It's going to take a while. And then once we have the cache, we'll start focusing on rendering.